Assalamu alaikum, dear students. I hope you will be fine and heal. So this presentation and is about our practical course AGR 718 Pop Modeling. So in this presentation, I will introduce about the student course system for agrotechnology transfer model. So this is a part of our practicals, and in this slide, I will mainly focus on the introduction and overview about the DSAT model. So let's start our so this is DSAT model. So in this presentation, I will talk about history and overview about the DSAT and some relators and also some application of the DSAT models and how to download it. And if we have a question, we can go its website. So there are many things about it. I think this presentation will be very useful for you. So when and where crop modeling is started, especially this information is about the Dutch and the US researcher. Modeling is not very new. So it is started in the late 1960s. So especially the modeling is a design that is wanted methods to predict crop growth and yield to better design management system and to quantify effects of the weather. So there are a number of researchers involved in the beginning of the development of the models. The most important is the CTD Witt from the Netherlands. So he played a very important role in the development of the modeling and introduced new concepts about the models, how to predict crop growth and yield of the plants by using some numerical function. So later on, so, many other scientists from USA like Bill Duncan's, Herb Stapleton's, Jerry Lambert, Don Becker, Bopper, and Bruce Corey from USA, and evolved into a Dutch models growth and US cotton maize and peanut models. Also created crop modeling community which still function today like a biological simulation crop modeling group. So here is the evolution of the crop modeling history about timelines of the model, just like mainly is work from the Dutch and the USA in the early is started work in the 1970s. The growth family of the model is Rhiza has been developed from the Dutch family. Then is a Cort mod, Simcord, the Supium, and cotton mud that is actually is developed 1980s and is developed from the French scientists. Then it's 1980s USA USDA from ARS Agriculture uh, Services Department has played a very important role. They work on the glycine model and soy model from the Iowa State and also like peanut grow models and then is also development of the DSET model from the Michigan State University. And then is also stress wheat and maize that is generic model developed by the Hawaii. And then is Epsom is from the Aspro from the Australia group has been introduced in the 90 late in the 1990s. So there are some major group working on the modeling. Some effort just like Espro from Australia, Stick from France, Cross from Netherlands, DSAT USA, Demeter Germany, Max Planck Institute, Infocrop India, and is Aquacrop from F. Some major crop modeling efforts have been introduced by the EPIC is from the USA, from Texas, and crop system is from the Washington State, and are that the BPM model from USDA, ARS, Agriculture Research Services. So there are also many other some are affiliated with one or more of the above groups like they are working in Canada, Australia, USA, UK, Denmark, Germany, Argentina, Spain, Italy, Japan, and some independently work. Some is a historical note on the IBS net project. This is an international benchmark site network for agrotechnology transfer project started in the 1982. So this project has introduced many concepts and they actually introduced and gathers many scientists at one platform. So some information related to this project, soil project, technology transfer via soil taxonomy ended in 1982. Then IBS net project started 1982, remain 93. And also introduced from 83 to from 86, introduced about the minimum data concepts. So about the minimum data concept, this is I will introduce in the next lectures. These concepts, what kind of the minimum data at least required to run models. Then these initial models were like a stress maize, stress wheat, and soy grow and soybean model. Data standard for compatible to the models introduced in 1986 to 1994. So that is very important how the files are compatible with the models because that times many models that are working, so they have different a standard format for their own. So, but later on they introduce some standardizations for the file. How can one file can be moved from one model to another? So then the DSAT model version 2.1 is released in 1986. First model, then is Akasa is formed in 1994. Akasa restructured in 2002 and 2003, and DSAT model 3.5 released in 1998. After project and DSAT copying system model 4 is released, and then is now is 4.2 in April 2006, 4.5 in 2012, 4.6 in 2014, and 4.7 in 2019 was released. So I based that projects some achievement based at University of Hawaii, and is mainly is Yuhara is mainly is principally investigator is funded by the USA. Then other scientists play a very important role like Nix Richie, Beridan, Tony Hurt, Paul Tang, and Juan Murma on technical advisory board. International network of researchers interested in applying system tools to cropping system and system sciences. Then some product like DSAT new is 4.7, 6 and 7 is in the final testing phase workshop. Data structure and currently network of the trained user more than 2000. Some issues goal for transferability of the soil research result, gap between information needed and then created by traditional trial and error, soil and agronomic research, high cost of the field experimentation, integration of the knowledge is needed. Furthermore, there are increased demand for agricultural products, food, feed, fiber, and fuel, increased pressure on soil and natural resources, climate-related risk, climate variability, climate change, complex, non-linear interaction among factors, rapid change in technology, information needed for decision-making, farmer, policymaker, some guideline principle focus on experiment data and understanding performance. Common minimum data requirement model and experiment are complementary. Model data are broadly applicable. Model must be evaluated and used judicially. Application of the model to optimize management to achieve desired goals. DSAT is a tool that actually is based on the science-based tool. So a biophysical crop, soil weather management tool, application package and tool. So crop simulation model based on understanding of the plant, soil, weather management interaction, just like morphological, phenological development, photosynthesis, respiration, growth, and root, water uptake, stress effects on growth processes. Then it can predict growth, yield, and timing. These are the outputs. But what some function, some information that are required as an input data to the model, just like the field, soil characteristics, weather, daily information of the weather data, cultivar characteristic management can be used to perform what if experiment. Cropping system model in DSAT evolved from stress maize and stress wheat by the John Ritchie and the John, and from soy grow model and peanut grow model from the Booty and the Jones. Originally, these were individual programs, each having its own soil, crop management, weather component. Major difficulty in compatibility, maintenance, and adding new crops. This led to the creation of the DSAT name in 1985 and the first release in 1986 with maize, wheat, soybean, and peanut crop. So these are the cropping system modules in the DSAT model main program. Then is a land unit module, weather, management, soil plant, atmosphere, plant. Then is a secondary module just like the tillage, planting, organic matter application, fertilizer application, irrigation, harvesting. When we talk about the soil modules, the soil dynamics, soil water, soil inorganic nitrogen, soil inorganic phosphorus, soil organic matter. When talk about soil plant interaction, soil temperature, and the potential evapotranspiration, soil uh, uh, application, soil transportation, and then is also included with the century model. When talk about the plant is a crop growth, stress model, stress maize, stress rice, stress wheat, and a sub store for the potato and many other crops. Module characteristics for the DSAT model, read its own parameter, initialize itself, accept variable from other module, pass variable, compute in modules on its state variable, compute rate of the change for its state variable, integrate its own state variable, write its own variable as output, operate independently. So these are the here main modules in the DSAT model cropping system, like a crops. In the crops, like a crop grow template, grain, legumes, soybean, peanut, rye, bean, faba bean, and macuna. Crop grow template for other like tomato, cotton, pasture, and stress, maize, important wise, stress wise, stress crop, a system wheat for barley, and stress sorghum, stress millet, and store for potato, and can grow for sugarcane, and gas grow in version 4.5, and crop system cassava, and many others. Then is a module for the soil, like include water, temperature, carbon and nitrogen, phosphorus, potassium, and when talk about the environment, weather data, weather modification, all is included in the environment module. Soil plant atmospheres management and disease management. So this is one of the overview of the program that I already explained in previous slides. So when talk about DSAT, what is actually DSAT? Research tool for crop production analysis. So simply state, we can say incorporate soil crop weather modules, analysis tool, uncertainty analysis, economic analysis, sports software, graphic, weather data generator, also linked with the GIS for special variability analysis, utility to help user to integrate data with different. This ad is designed to allow user to adopt and evaluate model for their own condition, incorporate their own data in a standard format, provide insight into what if question about production, profitability, and stability. Assist researcher understand response and interaction data in the field. These are the component of the model, just like a database. We need like input information we need to be put here, like weather information, soil information, genetics, test, experiment, and economics. Then is the modules that is compute different modules related to the input data, like crop models, and also include with the and supported with the software, just like a graphic software, weather software, soil-based software, and experiment, test, genetic economics, and application. We can have a number of applications by using the SAT model, just like validation, sensitivity analysis, seasonal strategy analysis, crop rotation, sequence analysis, special variability analysis by linking GS. So we have also this at a user interface, just like we have Windows. This is Windows-based program. This set is also released for the Mac currently. It also can be used on the Mac system. Evaluation crop models for intended application is critically important for sensitivity analysis, critical evaluate result based on the existing knowledge, demonstrate ability to recreate results, and also conclusion from the model agree with the conclusion from the experiment, evaluate using independent data sets, and be critical and also solution for this model. These are some of the experiments that we have already performed by using these set models. Already some of the application trend is showing by situation measure. So what kind of application we can be used by using this set model, like a diagnose problem, yield gap analysis, precision can be used in precision agriculture, diagnose factor causing yield variation, prescribe especially variable management, water and irrigation management, soil fertility management, plant breeding and genotype and environment interaction, virtual crop models. We can be develop some visual varieties just to save our times and resources for long-term experiment, yield prediction for crop management. And climate variability, risk management, climate change impact and adaptation, soil carbon sequestration, land use change analysis, targeting aid, early warning, biofuel production, risk insurance, rainfall, and example some study the study background. So other information about the IBSNet project is the CASA International Consortium for Agriculture System Application, combine farmer IBSNet project with the Netherlands System Science effort, started December 1993, global network for participating scientists institution, activities, CASA data standards, CASA.net, and www.dsat.net. So CASA DSAT membership initial phase 1993 to 1996 started at Washington State University, started by the Ricci expansion 1987 to 2002, added ASPRO and Indian scientist group John and Buma, and expanded participation from 2003 to 2011. Internet focused activities, membership management, and then is Jeff White and Van Estrom's new DSAT Foundation phase in 2012. DSAT Foundation and mode of the operation. Party, participated design development application, no central funding, share tool, core data scientists both provide and receive. This is a link for the website for DSAT. So this is a DSAT Foundation initiative. They have developed their own websites. It is free to access, can be downloaded. Just only registration is required. So right now more than 4,200 distribution has already provided to the people. Source code upon can be get upon request. Workshop and training every year's standard protocol and data archive and exchange, development of the toolkit, publication, dissemination, listed server more than 4,500 users member. So this is the links about the websites of the DSAT model. So you can go to the click on the dsat.net and go to the, you can see this is the 4.75 version is released now. So here is, if you want to go to the download this software, it's free of cost. You go to this side, request for website on the download this at upon 4.7. So if you go this, so you can download, have a request form, just you enter the email, they will send the key of the DSAT, you can download this model. If you go to the DSAT model activities, so on the front page, you can go last year in 2019 September, so we held a DSAT training conference in PMS Agriculture University Rawalpindi by me. So this is the groups. If you see here is a more activity, you can find what kind of activities we have done in 2019. These are the clips of the activities. So if you have any question regarding this, regarding the DSATs model, something, you can go on his own website. So you can ask directly to me. You have a lot of material related to the how it works, what kind of the modules you are, what kind of the application you can find. So thank you very much. This is all for this presentation. Thank you very much.